Okay, so limits involving infinity, right? So the difference is that instead of taking x approaching a number, right? That's what everything we've done so far. X approaching 0, right? X approaching 3. We are making x approaching to infinity. So that's one of them, okay? Another one is, so it has two parts, okay? One part is we make x very big and see what happens. The other part is we make x approaching a number, okay? So over here, x approaching a number. But then the answer is either positive infinity or negative infinity. Okay, second scenario is when x approaches infinity, right? So both scenario has infinity inside. So that's why I grouped them together. Has to do with limits having infinities. Okay, so instead of reading this, right, this whole big paragraph here, we'll try with the question, and then once we go over the question A, we can go back, look at the definition. Will be easier to understand, okay? So let's look at question 14 first. So please, everybody turn to the page, okay, page 13. So for each function, determine the vertical asymptote, okay? So let's underline that, that's our goal, right? And both left and right limits, okay? So so in this section, it can help us to find asymptotes, okay? So the way we can set up is we take the limit. Okay, I want to make it approach a number, right? That's our first type. So which number should we be approaching? So you look at this function. It's a rational function, right? How do we normally find vertical asymptote? Carrie?
Is it like the bottom portion? So like the denominator? You have to, yeah.
Denominator, what do we do?
Has to, so denominator has to equal 0.
Yeah, okay. So that's when the function is undefined, right?
Yeah.
Okay, so what makes the denominator equals to 0, Jeffy?
Just positive 3.
Yeah, very good. Okay, so at 3 is where the vertical asymptote happens. Okay, we'll write it on the side first. So vertical asymptote is when x minus 3 equal to 0, which is x equal to 3. So 3 is where the graph has something special happen. So when we take the limit, we're gonna take x approaching 3 and then see what happens on either side of 3, okay? So let's say I do 3, approaching 3 from the left side of 9 over x minus 3 to the 5. Okay, so remember limit is, we can find limit by subbing it in, right? So, but if I just sub in 3 at undefined, right? But I want to get more detail out of undefined because undefined could involve positive infinity, could involve negative infinity. Okay, so let's see which one we will get. Okay, so what we can do is we pick a number that is a little bit smaller than 3. Okay, so Lex, can you pick a number smaller than 3?
2.
I want something just a little bit smaller.
2.99999.
Yeah, 2.999. Okay, we can just use 2.9, right? So if 2.9 goes into the bracket in the denominator, then the bracket will be close to what number, Emily?
0, probably.
Yep, like 2.999 minus 3, right? It will be close to 0, but is it bigger than 0 or less than 0? Jesse? Jesse?
Oh, sorry. I keep hearing Jeffy. I don't even know why. It's going to
Okay.
be negative.
Okay, a little bit smaller than 0,
Yeah.
so it will be negative, right? So the way we will show the step, we'll write it as 9 over 0 with a minus. So that means it's a little bit on the left side of 0, and then to the 5. Okay, and then 0 negative. So you can think of it as negative 0.001, right? If I raise it to the exponent of 5, will the result be positive or negative, Leon?
Negative.
Yeah, it will be stay negative, right? It's an odd exponent, so it'll be 9 over 0 negative still. Okay, so it's a vague idea, right? So the 0 negative in this step is different from this one, right? Because the one on the right side is even smaller, but they are both very close to 0. Okay, keep the idea of limit, right? It's just really close to 0, but just make sure you know it's a negative value. So now if we divide, the top is positive, right? Positive divided by negative will become negative. And 9 divided by a very small number, what would it equal to, Nicole?
Wait, sorry, can you repeat that? My speakers are weird.
Yeah, do you get everything up to so far? Up to 9?
Yeah.
Yeah. So my question is, if I divide 9 by 0.00001, right, a small number, what will happen?
It gets bigger.
Yeah, very big, okay? You can try with a calculator, 9 divided by 0.000000001, right? So it will be infinity, but since the top is positive, the denominator is negative, so you get negative infinity. Okay, so this is how we show the steps, right? Using the symbol, right? 0 on the right side, 0 on the left side to determine whether the result is positive or negative, all right? You know it's going to be infinity. You just need to make sure if it's positive or negative. So let's try this one, okay? The one coming from the right side. So same function. And also pay attention when I stop writing the limit, right? I stop writing limit once I input the number into x. Once the x disappears, then you don't need to write the limit. All right, so Jeffy, what do I write on the next step now? Jeffy?
Oh, wait, I thought you said yes.
Okay, we need to find a way to clarify your names.
Okay, my
right?
name will be Senor Chicken.
Okay, Senor Chicken. Okay,
Yeah.
so I would like Jeffy to answer this first.
Okay.
Yeah.
You write the 0 positive and then exponent 5.
Yeah. Okay. 0 positive exponent 5, 9 over, right? And then that will be 9 over 0 positive, right? Because positive to the 5 is still positive. So positive divided by positive will be positive. So positive infinity. Okay. So pretty straightforward, right? No, nothing tricky. Just remember to check if it's bigger than 0 or less than 0. So how does that help us draw the graph? Okay, so we are going to make a picture. We know the vertical asymptote is at 3. So I'm going to mark 3 here and then draw a vertical line. So the first limit up there is saying we want to draw the graph coming from the left side of 3. And the result is going to be negative infinity. The result here, they're all talking about the y values. Okay, these are the y values of the graph, right? Because you sub in the x. So coming from the left, it will go negative, very big, right? So that means it goes down, right? Because y is up and down. So it'll be going this way. So that's coming from the left side, it'll go down. And then from the right side, it'll go up, right? Because positive infinity. Okay, before we learning about limits in grade 10, grade 11, we used to make table of values. So now you don't need to, right? You can figure out the pattern, the trend, where it will go, right? Whether it goes up or go down using the limits. Okay, so that's one application. You can use it to figure out what happens around vertical asymptote. Anyone has question so far? Okay, because it's gonna be your turn to try the next one. Okay, so question B, I'm gonna let you carry out this whole question. Okay, and then I'll ask some of you to draw the graph later. All right, so get the limit from either side. First, you write out the vertical asymptote, and then do the limit from each side and make a graph. Okay, once you got everything done, then raise your hand.
Wait, Senor? I mean, Mr.
Yeah.
No, Jason. It's just Jason.
Senior chicken.
Yeah. There's still horizontal asymptote, right?
Yes, but here we just focus on vertical asymptote.
Oh, okay, okay.
Don't worry about the drawing the horizontal right now.
Okay, okay. Thank you.
You're welcome. Okay, remember to raise your hand if you finished. And the variable is t here, right? So you remember to write t approaching, okay? You need to adapt to different questions. Okay, Leon, can you help us draw the asymptote? Where the asymptote is?
-6.
Yeah. Could you help us draw it out on the screen? So x equal t equals. Okay, very good. And make sure you label it, right? 1, 2, 3, 4, 5, 6. Yep, very good. All right, and Emily, could you draw the right side of the curve?
Oh shoot, I'm so sorry.
Okay.
Just get rid of that. The right side, right?
Yep, right side, approaching from the right.
Something like that.
Okay, so going up. So that means,
Yeah.
let me write that down then. So approaching from the right, it will be positive infinity. Okay, how about Nicole? Could you help us draw from the left side?
How do you draw?
You can find the annotate function.
Oh, okay.
Yeah.
Oh, is it the left side?
Yeah, left side. Right side is already done.
I
Wait,
think I
Jason.
might have done it wrong.
What do you have? You just
Mine
draw.
is like this.
Okay, so both sides approaching up. So also in positive infinity, is it?
Wait, Jason.
Yes.
I got the same as Nicole. Like I got
Yeah.
approaching from the left side. I got, or no, approaching from the. Oh yeah, approaching from the left side. I got positive, but then approaching from the right side, I
Approaching
got
right side
negative.
is negative.
Approaching from the
Oh, maybe I messed up.
right side is negative.
Yeah,
I
that's what
probably
got.
did. Hold on a second.
Let's check another person, right? Okay. How about Lex? What about you? Which side did you get positive?
My right side is going up.
Your right side, so you agree with Emily then, right?
Mm.
Okay. How about your left side, Lex?
It's going down.
Going down. Okay, so left side is negative. Okay, so like about half. Okay, let's see what happens. Well, it's possible that we have both sides positive, okay, or both sides negative even, right? So really depends on the question. So never assume anything, right? So let's see how we sub it in, right? So we choose a number on the right side of -6. So Emily, pick a number on the right side of -6.
Negative 5.9.
Yep, a little bit bigger than -6, right? So the bottom part will be 6 minus 5.9. So that will be close to 0 and positive or negative, Emily?
Positive.
Yeah, right? Because it's 6 minus 5.9, right? Or 5.999, right? So it's just a little bit bigger than 0. Now for the top. For the top, because it doesn't matter how close you get close to -6, it doesn't make it 0. We only care about 0 positive, 0 negative, right? Because one number is positive, one number is negative. But if you have, let's say, 10, a little bit bigger than 10, a little bit smaller than 10, it doesn't really matter. They are just close to 10. It doesn't make much difference. Do you get what I mean? Okay, for 0 positive, 0 negative is night and day, right? One is positive, one is negative. But for 10 positive, 10 negative, they are just both positive values. So for the top, we can just simply sub in -6. Okay, so -6, if I plug it in, it will be -12. The value will be close to -12. It doesn't matter which side it came from. It will just be close to -12. Anyone has question about this concept here? Okay. So now if we divide, right, negative divided by positive, it will become a negative. So it should be negative infinity. Okay, are we good? So let's look at next one, right? So next one, the top, we know it will be -12. And then denominator will be 6, a little bit smaller than 0 then, right? Because it's more negative than -6. And then negative divided by negative will be positive, so positive infinity. Okay, so our final graph coming from the right side, it will be going down. Okay, we didn't talk about the horizontal asymptote here, so don't worry about where horizontal is, right? Just check the arrow for up and down. And then from the left side, it will be going up, so going up like that. Okay, so let's clear the annotate and asymptote. All right, so I hope you feel better about how to do this now? Okay, let's try question C. All right, so same thing. I'll let you figure that out first. And when you finish, please raise your hand. Okay, Joan, can you draw the vertical asymptote for us?
Sure. Let me just figure it out because sometimes my annotate thing doesn't work.
Mm-hmm. Yep, very good. -1. Okay. Right, and Carrie, Leon, any questions? You guys done? Yep, okay. Leon, can you draw the right side? So approaching -1 from the right, you have positive infinity. Okay, how about Emily? Left side? Will be negative infinity. Is that right, Emily?
Yep.
Yep. Okay. Anyone got different? Lex? Do you have the same or different?
I have a different one.
Okay. What kind do you have?
They're both,
Huh?
they're both positive.
Which one positive?
Both of them.
Both of them positive. So positive infinity, positive infinity. Okay.
Yeah.
How about Joan?
I got the first answer, so from the right it's positive and from the left it's negative.
Okay. And chicken? Is anyone chicken?
I got same as Joan and Emily.
So positive and negative. Okay.
Yeah.
Carrie, how about you?
I got both positive.
Both positive. Okay. Okay. Anyone else got? How about Jeffy? What do you have?
Negative infinity approaching from the left, positive infinity from the right.
So it feels like half again, huh? So let's find out. Okay. So we are ready. We are not ready to launch. Okay. So let's see. So we plug in a little bit bigger than -1, right? So let's start from the denominator, right? So what number would you choose, Jesse? A little bit bigger than -1.
Wait, me?
Oh, sorry, chicken.
Wait, sorry, I was confused. I picked like 0 point, or no, negative 0.999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999. And if you add one to that, the answer will be will become what? Chicken? Oh, that's like positive, like 0 plus, right?
Yeah, 0 plus, a little bit bigger than 0. And then we want to square that, right?
Yeah.
And then for the numerator, we just simply plug in -1. We don't care about left or right side because it doesn't make it 0, okay? So that will just be 2. All right? So 2 divided by, if it's square, of course, positive, remains positive. So that will give you, so everybody got this one right, okay? Positive infinity. Okay, so the moment of truth. Next one, same thing. We're gonna plug in a little bit smaller than -1. So Nicole, what do you pick? What number do you sub in?
I put in -1.000001.
And if you add 1 to that, the answer will be
-0.
okay. So 0 minus, like that, right? Yeah.
Yeah.
Okay. Now for the top, same thing. -1 plugging in will still be 2. And then the denominator, what happens now, Jung?
It's gonna be positive.
Yeah, because it's a little tiny negative number times it again, right, by itself. So negative will be positive 0. Okay, so 2 divided by a small positive will be a big positive number. Make sense, everyone? Right? I kind of gave you a hint. It could happen, right? You could have both sides positive. Okay, so the graph should go up. Oops. Here, go up and go up. Okay, for this one. Let's clear the annotation. Okay. I think I want to do one more, okay, just to make sure everybody gets it, right? So let's look at next one. So question D, okay, before I let you try it all by yourself, let's discuss a little bit, okay? What do you think we should do here first? Where's the mouse?
Jason?
Yeah.
Isn't there like 2 vertical asymptote?
How do you know?
Plus minus 2, because x squared minus 4 is x plus 2x minus 2.
Yeah, okay, so we can factor it into x plus 2, x minus 2 equals 0. We get x equal to 2 and -2. So we get vertical asymptotes. Yeah, okay, so now if everybody agree on that, then that means we have 4 sides to discuss, okay? So that will be a lot of work here. So we can do one side, that's for x equal to 2. We do the limit of left and right. And then we do the -2, and then we approach left and right. And then we make a single graph in the middle. Okay, so that's the setup. You can try now, right? So when you're done, raise your hand. The second time, we're gonna go a bit faster. I mean, this time, this is the fourth time, right? Fourth question. So we just discuss in the air, talk about what answer you got. I will draw the asymptote for you. So 1 is at 2. 1 is at -2. Anyone has questions? So you would have 4 graphs, okay? 2 for each asymptote. Leon, John, any questions?
I'm just really slow at this. My bad.
Okay. I'm just making sure you're on still on the.
Yeah, so far it's fine.
Okay. Okay, how about Leon? Could you draw the 4 graphs that you have on the screen? Okay, how about, thank you. Jeffy, how about you?
Do you want me to draw it or?
Yeah, do you have the same or something different?
No, I have the same thing.
You have the same, okay. Emily, how about you?
Same thing.
Same thing. Lex? Lex?
Same thing.
Same thing, okay. Carrie?
Same thing.
Same thing, okay. Looks like this time.
No, I most definitely did not get the same thing.
Oh, Jesse did. Okay.
Yeah.
What do you have? Can
Okay,
you
because like if there's like two vertical asymptotes, then the one in the middle is either like a tangent graph or it has to be a parabola, right?
don't worry about those things. You got to follow the limits, okay?
Okay, then it's the same thing. I was just
Oh.
wondering because like if you plug in 0 into the x, then the middle point's different.
Okay, it could be higher, right? Because we didn't talk about what's happening in the middle,
Yeah.
right? So maybe the middle curve maybe is something higher, right? Or something lower, right?
Okay.
Or yeah, but you just need to know that it's going downwards, right?
Yeah.
Okay.
Okay.
Okay, let me clear that up. Okay. So left side of 2, okay? So based on your answer, this will be negative infinity, right? And then from the right will be positive infinity. Negative 2 from the left will be positive, and then this one is negative infinity, okay? That's good. Later, of course, we'll talk about what happened. Right now, we're just drawing the vertical asymptote, right? So we don't know what's going on in the middle. And then once we learn everything, we can combine it together and then get a more accurate graph. Joan, are you doing okay getting these answers?
Yep, I got the same things.
Okay, great. All right, everyone is on the same page now. Okay, so let's move on to next part, okay, which is horizontal asymptote, okay, over here. Oh, by the way, let's go back, okay, because I forgot to go back, look at the definition, right? So basically now if you look at the sentence, it will be much easier to understand, right? So if I tell you the function is defined on an interval, so this represent interval, okay? It's not a point. So a is a number, for example, like 3, right? And because the round brackets here, these are called open interval. Okay, if you forgot why, you should have learned it in grade 10. So basically, for example, this one, it means the x value is bigger than a and smaller than infinity. Or you just simply write x is bigger than a. Okay. Right, and then this interval is saying that x is smaller than a. And because it doesn't have equal sign, because a is where the vertical asymptote happens. Okay, so the graph doesn't have any point on a. Okay, that's why it's open interval. Okay, open means it doesn't have equal sign. Okay, and the next part, if we take x sufficiently close to a, so that's the limit, right? X very close to 3, for example, in question A, from one side, so it could be left side or right side, such that the y value, right, this means the y, f of x, is large positive or negative. So that means positive infinity, negative infinity, okay, in words. Then we'll say the limit as x approaching a from the left or from the right is infinity or negative infinity. Or you can just say DNE, right? But here we got more detail out of it, right? You can figure out it's going up or down. And then the line will be called the vertical asymptote. So you can box that, right? This is the vertical asymptote. So the limit answer, right? The answer to the limit must be infinity. Then you can say it's a vertical asymptote, right? So the notation you could have approaching from the right side, right? You gain infinity. Or approaching from the left side, you gain infinity, right? So just try to connect the sentence with the examples, okay? Because this is the type of wording that you'll be seeing in the textbook. right? So I just throw it here so you can learn how to break it down, right? So the way you can understand when you read a textbook, when you go to university, right? You try to do some questions first and then go back and look at it, and it will make more sense, okay? All right, so let's go to next page. So the second type is going to take x to infinity instead, right? Instead of x approaching a number, we will make x very big. So same thing, we're gonna skip the sentence for now, okay? We'll try an example down here. So here I would like everyone to grab your calculator, okay? Everyone has a calculator, you can use a phone if you want. So here, use table of value, find the limit of f of x equal to this, right? So this is a function. As x grows infinitely positive or negative. So if you look at the values, if you start from 0, x equal to 0, I will plug that in for you, right? So 0 goes in, so f of 0, that will make everything on the top equal to -1. Over the bottom is 1, so it'll be -1, right? And then starting from here, I want to approach very big, right? 10,000. And then left side will be -10,000. So going to the left is negative infinity. Going to the right side is positive infinity. All right, so please plug in every single point into the x, and then we'll check the values, okay? And once you got the table, please raise your hand. And this one will take a bit longer to type it in. Okay, so don't worry, take your time. Make sure you have brackets. Okay, when you type into your calculator, it's the whole thing on the top, divide by the whole things at the bottom. Okay, make sure you use the correct brackets. Okay, Jeffy, what's your answer for x equal to 1?
1.
1?
Yep.
Okay. Emily, how about 10?
I have 2.0693.
Okay. Okay, Jesse, how about 100?
Like Jason,
Yes?
for
Chicken?
1, I got 3/2.
3 over 2. 3 over 2, so 1.5.
Oh yeah, sure. Oh wait, I have everything in fraction because my like calculator is like messed up, so I just did it like in fraction.
Okay, and it will be easier to see the pattern, right, if it's in decimal.
Oh, okay. Sorry.
Jeffy, can you double check your 1? X equal to 1?
I just did. I still got 1.
You still got 1. How about Emily? What's
Give me
your
a moment. I also have 1.
okay? Senor Chicken, can you also
Wait,
1?
but then two times 1 squared is 2.
Yep.
2 plus 1 is. Oh, sorry. I thought x was 2. My bad.
Okay. Okay. So we all good, right? X equal to 1.
Yeah. Sorry. I thought x was 2.
No worries. Okay. That's teamwork, right? Okay, Lex, what's your answer for 100?
For 100, I got 2.0096.
0096. Thank you. Okay, Nicole, what about 10,000?
I have it in fraction.
Could you tell me decimal?
Yep. Um, 2.000996.
Like that?
Yeah.
Yeah. Okay. Right. We still have 3 people. Please raise your hand if you finish the whole table. Okay, John, what's your answer for -1?
I got 0.
0. Okay. Anyone disagree? Okay, Carrie, what's your answer for -10?
I got 1.87.
1.87. Okay. Leon, how about -100?
1.99.
99. Okay. All right. And Emily, how about -10,000?
1.99989.
99989. Okay.
Yeah.
So if you look at the pattern here, right? We are not going to make table every time. This is just explaining what's going on with limits. Okay. So when we take the limit as x approaching to infinity, right? This is how we can explain what's going on here. X gets very big and our function is this one, right? So you put the function behind as always. And then the answer is to see what happened, right? What happens to the y value. So as we go to the right side, the value of the y is approaching what, Carrie?
2.
So the answer will be 2. So 2 will be called the limit, even though it doesn't equal to 2, but it's close enough. We just say limit is 2. Now, if we go to the left side, it will be also be close to 2, right? It's 1.9989, but it's a little bit lower, but the limit is still 2. Okay, so you can write, we can write it equal, right? Limit x approaching negative infinity of the same function. So both of them equals to 2. So when that happens, you can say there's a horizontal asymptote is y equal to 2. Okay, and remember asymptote is a place that's empty, right? So the y value will never equal to 2, but it's a space that the graph is getting close to, okay? So, but then the left and right side doesn't always equal each other, okay? In this example, left and right both equal to 2, right? You could have one side approaching to 2 and then the other side approaching to -1, right? That could also happen. So you could have 2 different horizontal asymptotes on each side, okay? Later you might see a graph like that. Okay, so that's, so on the graph, okay, let's find a little space on the top. So on the graph, it will look like this. Horizontal is at 2. And then approaching to the right side is above, right? Higher than 2. So it'll be coming from the top. Okay, so it actually tells you which side it comes from. And then left side is 1.9989. So it's a little bit smaller than 2. So it has to come from the bottom part. Okay, approaching 2, they are both approaching 2, but they are coming from different side of the world, right? One from heaven, one from the ground. All right, so we can use, so far we learned 2 kinds of infinity, right? The first kind is to find vertical asymptote. Second kind is for you to check horizontal asymptote. And if we combine both, then we can know exactly where the graph will look like, right? Next part, we're gonna look at the theorem, which is, well, so far, right now we use table to find the limit, but we don't want to always use the table, right? It takes too long to type it in. So we have a theorem to help us calculate. So later we have different examples using the theorem to do it. So basically what it's saying is that if the function looks like this form, c is a constant, right? So for example, if I have limit, let's say x approaching, doesn't matter which way, right? Plus or minus infinity. And if I have 5 over x to p, p is any positive real number, okay? So can you give me an example of a positive real number, Nicole?
1.
Okay, okay, 1. Yeah, that's also a positive real number. So if it satisfies these condition, right? The top is a constant, the bottom has a positive real number for exponent, then the answer will be 0. Okay, so even if it's like a decimal, right? 3.5, it will still work. So what you can do to understand why it works is the numerator, it never change. It's a constant. But denominator just gets bigger and bigger and bigger, right? Even if it goes to negative side, it's still just gonna blow up, right? And then something divided by a very huge number will be just close to 0. Okay, so that's why this theorem always works. So we can use that to help us find some limits here. So let's look at question A. So you have limit of this one, right? Well, I want to find limit of this function. Of course, we don't want to plug in anymore, right? And using the limit law from last class, okay? I don't know if you remember limit law, right? Those of you did the homework, finished homework, you should remember, right? We have limit of adding, we can split, right? Limit of f plus g, I can split into limit of each one. So basically we find limit of 1 by 1, right? So back to here, we have f plus g, right? So 2 function, we can find the limit of 2 and then find the limit of 10 over x squared. What happened when we take limit of a constant? Joan, you watched the video. Do you remember what happened when we take the limit of a constant?
The constant itself is like moved to the front. Does that make any sense?
That's which law you are thinking of? Let me. Which one you are talking about?
Oh wait, just kidding. Law 9.
Low
So
number.
it's just gonna be the constant itself.
Okay, so the one I can put it to the front if it's multiplying, right? Okay, low number 4. So low number 9, if it's a constant, will just stay there. So the answer for the first part will be 2. Okay, and then plus the limit of x approaching negative infinity of constant over x squared. So this is the part you use the rule, right? Constant divided by a variable to the exponent. Then it will always be 0. So it'll be 2 plus 0. So answer is 2. Okay? Let's look at another example. Question B, okay? Here it mentioned about squeeze theorem. Okay, so that's a good chance to review what we learned last week as well. So I would like you to try this on your own first. Okay, think about which part needs squeeze theorem. And this one has adding, right? So adding means you can use what we did on question A. Okay, we do it separately. So you find the limit of the 5 and then find the limit of sine x over root x. Okay, if you forgot how to do squeeze theorem, go back to the notes, okay?
Jason,
Yep.
I have a question about the sine x over root x part.
Mm-hmm.
Wait, when you're explaining it, can I ask you then?
Yep, sure.
Okay, thank you.
Yeah, that part you need to use squeeze theorem, okay?
Okay.
Go back, look at what we did in squeeze theorem. We did quite a few examples, right? You need to build a sandwich, right? Sine x over root x is your sandwich. You want to build that. So use this as a chance to review how to do squeeze theorem. Okay, if you finish, raise your hand. Is there anyone has no idea what to do to start? Let's take a look at squeeze theorem. You can think about either question B or C, right? It's similar to that, right? Question B has a fraction, right? Question C has a sign, right? Similar. Okay, I'll get through the easy part first. So we start by splitting it, right? we can take the limit of the 5, which will be 5, and then plus limit of sine x over root x. And then this part, you need to do it on the side using squeeze theorem. Okay, that's the idea.
Jason,
Yep.
am I allowed to change the root x or 1 over root x to x to the negative 1 over 2?
Yeah, you could.
Then that makes it legal, right?
Makes what?
Because like if I have like negative 1 over root x.
Negative 1 over 2.
No, okay. You know how you start with like sine x, right?
Yeah.
And then is in between negative 1 and 1.
Yeah.
If I have to put everything over root x,
Mm-hmm.
then I have like 1 over root x and negative 1 over root x, right?
Mm-hmm.
But then I can't have the bottom equal to 0.
But we are not approaching 0 though.
Right?
What are we approaching?
Oh, infinity.
Mm-hmm.
Wait, but then when we do squeeze theorem, don't we have to do approach? Oh, no, I saw it wrong. Thank you.
Okay. It depends on the question, right? If the question approaches 0, then you do approach 0. But here we're approaching infinity. And then before, when we did approaching 0, we use a different way to squeeze. We use absolute value. Okay. If you go back here, right? At the very beginning, squeeze theorem, we use absolute value to squeeze it at 0. Okay. And then for this one is approaching 0, and then we use negative 1 and 1 to squeeze it. Okay, you can try, right? So you have different ways to squeeze the sign. Anyone got stuck? Okay, so Joan, can you help me start with the squeeze theorem? How do we start making the sandwich?
Sure. I'm kind of unsure though, especially after what you just said, but I put or I try to start with sine x.
Mm-hmm.
I don't know like if I can do this though with what you said, like x approaches infinity, but I did the negative 1 is less than or greater to sine x less than or greater to 1.
Yeah, and then?
Okay, and then I just divided everything by root x, or which is also x to the power of a half.
Mm-hmm. So the negative 1 over root x
Mm-hmm.
and 1 over root x, right?
Mm-hmm.
Okay, and then?
And then I just wrote it so that it was x to the power of a half.
Okay, so you want to rewrite it as
Or like I rewrote it for the ones on the outside, so then when you actually calculate the limits for it, it'll equal 0 because of the theorem.
oh, okay, yeah, okay, so let me write it again. So it'll be root x and then negative 1 over x to the half. Is that what you mean?
Mm-hmm.
Yeah, and then that's an equal to 1 over x to the half.
Mm-hmm.
Okay, and then?
And then you just find the limits,
Mhm.
x approaching infinity for negative 1 over x to the power of half and 1 over x to the power of a half.
Mm-hmm. So it will be 1, yeah, so this one left side will equal to
0.
0, and then right side
Also 0.
also 0, therefore,
It's 0.
yeah,
Technically.
0, yeah, by the theorem, right? By squeeze theorem will be 0. Okay, so we'll go back in, right? You'll get 5 plus
Wait,
0.
Jason,
Yes.
how do you if you plug in infinity to negative x,
Negative
why is
x.
it 0?
Which part?
Or like, what if you plug in infinity into x? How come it's 0?
Part are you talking about?
Limit x approaching to infinity.
Oh, and then 1 over negative x to the half.
Yeah.
Okay, because you can try with the calculator. Let's say if you plug in 1,000 or 1,000,000, right? And then the top is just 1, right? When you take 1 divide by 1,000,000 squared,
Oh, okay.
the root,
I see.
it's still the bottom. It just gets bigger as the x gets bigger.
Yeah.
Okay?
So it's okay. Yeah. Okay.
Yeah. Or you can
Yeah.
use the theorem that we went over at the beginning, right? The 1 is the constant c,
Oh, yeah. Okay.
right? And that's why Joan decided to rewrite it as an exponent, right? The 1/2 is the p.
Okay.
Make sense?
Yeah. Thank
Okay.
you.
Yeah. So here the circle part here, or I'll make the start. Okay, these two part are the part we are using the theorem, right? Because it looks like a constant divided by x, right? Then once you apply it, whenever you see that happens, it always equal to 0 if it's infinite, and if x goes to infinity. So the answer will be 5 plus 0, so equals to 5. Okay, does anyone have question about any step here? Because half of you did not raise the hand, so I don't know if you have questions. Okay, so we'll take a break here for 15 minutes. After the break, let's see what will happen after the break, okay? After the break, we'll be going over some specific questions about limits. So there are different types. You have the polynomial type, you have the rational type, right, with fractions. The more difficult one is the one that has square roots. Okay, we'll be spending most of the time there. And then we will need to review some simple function like sine, graph, long graph, okay? So there are 4 types of question that has infinity inside. Okay, so I'll see you in 15 minutes. So that will be 6:25, okay? I'll see you then.
Thank you.
Yeah, you're welcome.
Jason,
Yes.
I need to go at 6:30. Do you still want me to come back for the 5 minutes?
Oh, you're.
Or do you just want me to like check the video later?
Yeah,
Because
you just check the video later, okay?
Okay.
And then do the homework too, okay?
Okay, so it's just the second video.
Yeah, yeah.
Okay. All right. Thanks, Jason.
You're welcome. Bye-bye.
Bye.